Hello, everyone. I'm still a bit in doubt about where to start the talk. Maybe first introduce myself to this group and then to the other one. It will be a bit hard also because it's dark here a bit. And so if I'm here, it's lighter. And well, we'll see what happens. Let's have some fun with that. Okay, so you may have heard about this very interesting technique to get rid of the ugly black box on the left. It's like spaghetti in a box, but it's if you sort of transform this thing magically, you will end up with very nice services as promised in all these nice little colors. And it's something known as the microservice journey, or trying to apply a microservice architecture to your system. I think it's good to get rid of the micro word there because it's such a difficult word to explain. Like how big is a microservice? How small is it? How many lines of code are in there? Do we have to use different programming languages, different databases even? So it brings a lot of extra questions. While the only thing that matters is you can now have separate things, and these should be more manageable. It doesn't even matter how many things there are, or how small, or how big. So, and this is what this talk is about. It's not about microservices. So I'm sorry if you were here for the microservices. It's about service design, and in particular about making services autonomous. And that is a difficult question. Like, how do we make these services autonomous? And we can think about that. Basically, there are three groups of developers. There is a very small group of people who actually do this kind of thing, multiple services working in an autonomous fashion in sort of a microservice architecture. Then there is a very large group of people who just will start saying things like, yeah, it's the same shit, and we write shit all day, and yeah, now once we start dividing it, we will just have an equal amount of shit, but just smaller shits. I don't know. I think this person became very famous with his tweet on microservices versus monoliths. So there's the group who is actually doing this. There's the group who hates it. And then there is the group of people who are basically only, like they would really love to do this thing. And they are looking for a way to deal with their microservice envy. And it's, they are talking to their team, like the next project we should definitely do with microservice architecture, and then of course every manager will say, no, we're not doing this. This will be over engineering from the start. We don't have the skills. We need operations, and yeah, this is why it usually doesn't happen. The same for me, really. I have no practical experience whatsoever with a microservice architecture. The only thing I did was dive into all the literature there is and trying to find the principles guiding these kinds of architectures. And that's where I think most teams are already going the wrong way. They are trying to make it work without thinking about how to design this whole thing. So that's why I'm doing talks on microservices without any actual practical experience. So now that you know this, you're here, so you might as well just stay here and learn from the principles. That's a trick I learned from Stefan. Just say that the door is closed and now you have to be here. You are in the wrong talk, but let's have some fun anyway. So how did I tackle my microservice envy? I'm sorry?
Conference-driven development.
Yes, so I'm just here to do a talk, and I did it, right? I even have two screens. You cannot wish for any more. Okay, so how did I tackle my own envy? Like I'm rid of this envy now. I wrote a book about this topic. I was bringing some, but unfortunately they are all gone already. But you can still order them online, of course. This will be, I think, interesting for PHP developers because even though it's sort of technology or language agnostic, there are PHP examples. And I was also trying to prove that we can do this kind of architecture with PHP. So yeah, if you're interested in that, you can still get it. What will be interesting to consider is that such a service-oriented architecture or service architecture where it's not about size, but it's about at least some division in terms of runtime processes. This can lead to interesting things in your team. So you can work separately on different services. That's great, because if you want to hire more people, you cannot all work together on the same piece of code. So now you can really scale your team. Besides that, you can of course also scale the actual running services. So if you have a bottleneck in your system, you can start duplicating the services, running them in parallel, and process more than you could before. By having the strict separation between these services, you basically can prevent those really big balls of mud or big spaghetti balls from going to exist in your team. So there is this natural way of preventing a mess. Then again, yeah, as I mentioned, it's also in some people's minds or eyes or experiences becoming very quickly a mess. So I'm not saying you can get rid of the mess. Yeah, you will get a different mess probably. So yeah, there is some easy advantages, I think, but you also need to worry a bit more about design. So there is a lot of cost to this thing as well. And if you're trying to get it right, the biggest problem is autonomy. If all of these services are in this network of things working together, yeah, if one of them breaks or is down or there is some issue with them, it's really bad for the system as a whole, because probably many things are depending on this one service that's now broken, and we don't want this. It's in a way really funny that we are wondering about what happens if a service is down, and then complain about, oh yeah, the whole system will be down, because if this is a monolith, the whole system will be down too. So what's really the fuss about that? The thing is, we were aiming for autonomy and for like high performance, high availability. So if this happens, it's a bad thing. We were trying to achieve something better than services breaking and taking away the whole functioning system. When we're looking for this autonomy, the thing is, yeah, of course, nobody is able to do something on their own. As a human being, this is true, but for services, it's the same thing. If you're looking for autonomous services and you think that it's just about the service does this one thing and it doesn't know nothing about other services, then it's going to be a really big problem, because you still have this very big use case you're implementing. And so at some point, services need to know something about each other to do their work well. And that's why, yeah, you will have to have this kind of network, but yeah, you need to sort of move the arrows in a different direction so that they don't take each other down when there's something wrong. Just when you're asking what could go wrong in this system, of course you know all these things. We could have very nasty technical issues at the level of the network, maybe even on hardware level, like disk drives failing. But there are so many other things that can go wrong. Maybe services start responding in a different way than you were expecting. Maybe they will say, you provided a bad request. Like that's a very bad thing to happen, of course, but that's maybe because some other team deployed a new version and suddenly you're supposed to provide different data to them. Yeah, so just many bad things could happen. One of the things that's not on the list is maybe the service you're trying to reach is currently being redeployed, so it's not even available, or while being redeployed, it's introducing a bug or something. So lots of stuff could go wrong, and then you have something that looks like this. Even though we have nicely applied hexagonal architecture to all these services, yeah, they are still going to explode, right? The first time this happened to me was back in 2000-something, 13, I guess, I don't know, when I was working at Dribit in Amsterdam, very nice company. I was the only one there creating plugins for Symfony 1, and they always made fun of me because of the vendor prefix, DR. So they said something like Dr. Twitter feed plugin and Dr. Symfony plugin. But anyway, this was my first encounter of a service or a web application that was just going down because of other services. This was used as an HTML component to render a list of tweets on the homepage of a web application that we're building there. And it would just connect to Twitter, get some tweets, and render a nice list of HTML. So, well, that was just what the customer asked for, right? I just made it work like that, and I made it a plugin so that people could reuse it in their project. But then what happened? Back in those days, Twitter was down very often, and you could see the fail wheel. I don't know if you remember that thing. Yeah, so this happened, and when that happened, the whole application went down as well, just because we had this one little box of Twitter, this one Twitter feed box on the homepage. So that was my first experience where the system administrator called me and said, you're doing something very wrong here. The whole thing is down. and not because of a programming mistake, but because of your mistake in thinking about this. And so I introduced an interesting solution there. This uses Doctrine 1, which was still active record back then, and it stored some of the tweets that it loaded in a database table. So that was just a cache, Doctrine 1 cache. And well, it can be sort of a nice solution. So what this did is first try if Twitter is online. If it's offline, just take what we already have. And whenever it's online, we just store the latest tweets in the database. I'm not sure what has happened to this database now. Like, what does the table look like? Maybe thousands or millions, or I don't know how many tweets are in there. But it's sort of the backup for Twitter itself, I think, these days. It is a nice solution, can be nice, but it's still very much synchronous. So we're making a call to another system, and if it's down, we try to fall back to another solution. I'm not talking about this kind of solution in this talk. So first we need to think about how our services connected to each other. What do they want from each other to do their work? And this happens in two ways. We either want to make a call to another service to make it do something. Like in this case, service A wants service B to do something. We call this a command. It's like imperative saying, do this, right? And then in another way, we want to know something from a different service. So A needs to know something about service B, something that B knows all about, and it will wait for an answer. So it makes the query and it waits for a return value to come back. And these are the two ways in which services need each other. So command and query. It's the same thing for many different programming topics. We have commands and queries everywhere. So it's the same for inter-service communication. And then there's always this annoying user who tries to do something with the system. They make a click on something. They probably fill in some form and post it. And the whole machine goes running. If you're a monolith, right, it will just be this one thing answering your request, doing everything it needs, and giving you the response. If it's a service system, you would see something like this. So one service calls another one. It needs some information from another one. This takes some time, and I think the response times are quite reasonably low, like even for the average PHP application. But then at some point, some service is busy, is having too much work to do. So it adds 2.5 seconds of response time. And maybe some of these services even going to crash. And then what do you do? Like in the whole process, something is wrong. Now what is the outcome of the whole process? What do we need to do with that? So we definitely don't want this to happen while the user is waiting for their answer, right? So what could we do? One little trick is to maybe do the first step, say we are working on it, and then process all of the remaining steps in the background afterwards. But yeah, this is nice. The user gets a fast response. They will well, be more or less confident that the system is going to take care of their action. But we still have this long chain of commands that is happening in the background. And even though the user isn't waiting anymore, well, there is still the risk that something is going wrong along this path. Like some service may break for all of the known reasons, and we still don't get what we want from it. That's where we need to actually change the way we program, the way we design. And there are different ways to name this approach. Yeah, you could say it's maybe event-driven. Reactive is an interesting name for it. The thing is, yeah, like reactive has so many other connotations. But anyway, I will show you what it looks like if you would talk about the actions of the system. In a very imperative way of programming, you would say, do this. It's like a recipe. Do this. Do that, and then do something else. Right? So it's just a list of things you have to do to accomplish a certain task. With more of an event-driven, message-driven, or reactive style, you would say, okay, like I mentioned, we do the first step. So do this. That's a given. And then when this has happened, do also that. And when that has happened, do something else. Just a single when thing, well, hints at, it's basically the same as you would have in old school JavaScript, like on click. So when a click happens, we're doing something. We're not just doing it now, we are waiting for something to happen. It's the same here. We are waiting for this to have happened, and then we go do that, right? And this is very different, a very different approach to the design of such systems. And it leads to very interesting things like the redistribution of knowledge. In the beginning, like in the original situation, we would have a service that knows when to do a certain thing, so what and when, and it will send a command to the other service that actually knows how to do it, right? And now we can make this a bit different. We only have the service on the left say, yeah, well, I did it. That's an event. And then the other services can respond to that because they know what to do, when to do it, because, well, that's after this event has happened. And they also know how to do it. So you have all the knowledge about this particular aspect of the process in one place. Yeah, you could compare this to inversion of control in the same way that we do this in our favorite frameworks. We use an event dispatcher. We say dispatch event, and then, well, event listeners or subscribers can do whatever they want with this event. They will just respond to this fact. And the one who is dispatching the event doesn't need to know all of the details about what has to happen next. What are the actions that are taken after that? So this is known as inversion of control. We don't control the outcome anymore. We let the others control the outcome based on what we tell them has happened. Still, there is the possibility that nobody is listening to our events. That's something people are very worried about, I know from experience. I'm also worried about that. And it's like in programmer discussions, it's always something like, yeah, but yeah, we rely on so many things to happen, so this is just one of the things that we cannot care about. I don't think it's right. You need a solution to know what is happening after your event has been dispatched or sent or emitted. So if nobody's listening, this is a very big thing. It's a very important thing to know. Because probably, and in most systems, an event, well, needs to have some further action taken. And only if all of the actions have been taken, yeah, we know that the process has been completed and something meaningful has been done. So we need to keep track of that. And also the same thing goes for failures again. So something may definitely go wrong when some service is processing the event and making some other change. I was mentioning processes already, and it's really like that. So when an event triggers some other things to be done, this is really a process, and we want to get some insight into the whole process. What has been going on, and where does it lead to? So yeah, what do we need? As developers, when we are dealing with something, we always just add manager to it, as in a class name, which is a manager. So if something is dealing with processes, we call it a process manager. And yeah, it's a bit of a stupid name, but it really is what it says it is. It manages a process. And it's really the thing you need. You want to keep track of whatever happens after some event has occurred. So a process manager subscribes to events. That's why the direction arrow is towards the event itself. So it listens to events, it consumes them, and then it produces new commands. Doesn't have to be commands only. It can also produce new events. But at least it's something that is responsible for doing this. It's making the link between an event and something that has to happen after this event. Besides making these calls, like creating the new commands or new events that need to happen afterwards, it also keeps track of state. So in the whole of this process, if we start something and we need to end somewhere else, the process manager also keeps track of where we are in this whole process. And this is very useful because it will store this information somewhere, doesn't really matter, just like storing something, yeah, could be in a database, and really then any kind of database. As long as it remembers where it is in the current process, yeah, you can find that out and even get some interesting insights in what's going on in the system. So the process manager in this case is sending a command to another service, and it's basically remembering that it's waiting for a result, for a response. And then when it happens, it will note that it has got the response. Maybe it will do something else, but at least now it could say, I'm done. Yeah. And yeah, even if something goes wrong on the other end, well, we could still remain in this same state and still remember what we still have left to do. So that's one way in which we can make sure that not an entire process is suddenly broken. We now know where we are and what needs to be done. So this is really should give you a lot more confidence in the whole system. I'd like to show just a nice example and to point out an interesting book on this topic. It's a bit old by now, but it has some good information on CQRS event sourcing and this kind of separated services or contexts, as they call this. An example of the process manager that deals with conference tickets, buying them and making seat reservations, and then finally committing the reservation or rejecting it. As you can see, it can become quite complicated, but this is the cost of having these services as independent things. But it's also the cost of realizing that there are all kinds of edge cases. Like if you would solve this in the monolithic way, then you could order a ticket, make a seat reservation, and sort of concurrently have other reservations making each other seat reservations, and then maybe even ending up with no seat at all. Where you may have bought the ticket but have no actual ticket or no place at the conference. So this shows all of the different outcomes. It shows the happy path, but also the not so happy path. And I find it very interesting to see that if you think about this kind of distributed systems, you wonder and you realize that there are more cases you didn't think of that are still possible and could happen. The way you can read the diagram is the process manager is in a certain state, and when then that's on the left, and when an event comes in, there are different things to be done. There is a new state to transition to, and there is a command to send. So there is a lot of work there, and there are also invalid states. Like you cannot once you have committed the reservation, you cannot get an event saying rejected the reservation. Like that's and you can guard your system against this kind of invalid state transitions too. So nobody will make bad changes to the database. You will know when something like that happens. So the process manager inside of it basically has a state machine. It manages valid state transactions. And this is a nice diagram of what can happen given a certain state when an event occurs, what's the next state, and for which kind of event are we really waiting, and what's the end result. The question is, where do all these events come from? Well, that's from all these nice little services with their nice little colors. As long as all the services let each other know what they have done, any service can respond to any of the effects that are happening in a remote part of the system, and they can do with it whatever they want. So they can respond to it, and nobody is giving anybody directions. It's just like they are responding to facts happening in different parts of the system. So solving this command issue where we really want to prevent ourselves from making calls to other services saying you have to do this. Like we don't want to send those commands anymore. We don't want to wait for a response anymore. The first step is to do something that the user asks. Like in the example of ordering conference tickets, you note that someone has in fact ordered these things, and then all the remaining steps are processed in the background. Sometimes this may take several days even, sometimes several hours, sometimes just 1 second. But at least when something is happening in this process, you will know where it went wrong and what's the current state and for which things people are actually waiting at the moment. And other services will do some more actions based on the events from other services. That's basically it. Nobody is saying do this anymore. So pretty interesting. And with these process managers, we can know what's going on. We can even list all of the states, how many people are waiting for payment, how many people are waiting for the reservation to come back. So that should be very interesting, and you can very easily create dashboards showing this kind of information. Now, what about the queries? Because I mentioned commands, queries. It's always this distinction. There's commands and queries. They even have different method signatures. So what about those? Because we still need to ask questions to other services. Like we want to know how many seats are available for this conference. So we need this answer before we can do anything. And that's, something we don't want, right? Because the service, when it calls the other service to know something, and if like service B is offline or producing bad responses, A is broken too. A can do nothing anymore. So that's a very bad situation. So we would no longer want to make this kind of query. So red cross, no longer make the query. How can we do this without losing the functionality that we still need? We still need to know this bit of information. Well, that's where we have to go a step deeper and ask ourselves, what is a query? And well, you could phrase it like this. What's the current state of something, something? So if I ask you about how did you get here, you know, yeah, we could figure that out. You could think about, oh, what has happened? I went by car or by train. But the question, like the end result, is still that you are here. This is the current state. So how did it occur? Because of many things, or you ordering tickets, or maybe someone else in your company bought the tickets. And so if you look one step further behind this, what is this current state thing? The current state is basically the result of all the past events. Of course, yeah, it's for us, it's all the past events, everything that has ever happened leads to you being here, which makes you very special people, of course. But for the computer, it's the same thing. We need to know, if you want to know the current state of something, you basically only need to know what has happened before this current moment. And as an example, like everything that has happened is just, like a thing that has happened is just the same as an event. So looking at the events at the top, we start with a start event. Well, not such an interesting event. We then go to a purchase event. This is an example from some warehouse-like system. We purchase 10 things, and then we sell 4 things. Based on just these events, we could derive the current state of what we have in stock, right? We can know what we have. So at the beginning, we have 0. All right, makes sense. Then we purchase 10 things. This means that in stock, we have now 10 things, right? And then we sell 4 things, meaning we have 6. It's really a simple calculation. But just using the events in this system, we can know what is the current state of the system. And with this trick, we can basically prevent ourselves from making queries. Because if instead of asking about the current state, we would know about every event that has happened, we can basically derive the current state. And this happens if you invert the dependency here. So instead of A needing information from B, B will already send out all of the information needed, basically what has happened to B itself, and then A can take out all of these events, all of these pieces of information, and finally build up its own current state. This means you will have copied state, like many services will know the same answers, but it will also make you less dependent, or in fact completely autonomous. Maybe you know this from event sourcing combined with CQRS. It's more or less this diagram. Different words can be used by different people, but at least we process a command. So something is about to change about our system. The command handler does this, the aggregate does this, and finally produces events, which are dispatched. And then there are projectors, so-called projectors, and they use these events to build up their own state, their own information about the current state. And we can use this in different ways. We can populate search engines or machine learning tools, all of this with just those event data. Just to mention it here, you don't really need event sourcing, also not in your event-driven or message-driven or microservice architecture. You completely don't need event sourcing there, as long as there is a way to let other services know what has happened to your service. So with event sourcing, like the biggest difference is with event sourcing, you store all of the events in an event store. Whenever you want to change something about an entity or aggregate, you will get out all of the events, the relevant events, and basically reconstitute your object, then make a change and add or append the events to the event store. Another way would just be to use your old-fashioned or maybe just modern ORM and let it handle the flushing to the database, etc., but still produce these events. And that's something I just wanted to mention, because it's always like, yeah, we cannot make services autonomous because we are not going to do event sourcing. That's just complicating stuff. So yeah, in this case, the idea is just we create events and we just dispatch them. It will be very useful if you can still store these events, because yeah, you also need to dispatch them physically. and it's good that if something is going wrong in that aspect, you still have the events locally, so you can try it again, try to dispatch them again. You also need something known as replay or rewind. All of these services are basically consumers of these events, these messages, and so they need to be able to keep up to date with all the newly added events, but they also need to go back in time, because they may do something wrong in their projection. They may have a mistake there, or there may be some new features, and so a consumer needs to go back in time to the beginning of time maybe, or to some time ago, and start reprocessing these events. And then it also needs to be able to listen to these events forever. So after it has been playing back, rewinding, going all over the older events, it needs to be updated about new events too. And in that way, we can basically solve the query issue, right? As long as services publish their events, and that's a funny thing because it's the same first step as in solving the command issue, services just need to say what they are doing. And if that's the case, then you can respond to that by doing more things or by keeping your own current state up to date. So other services will be able to subscribe to these events and use those events, take out the data they need to update their own current local state. And this will help them prevent from making calls to other services to get information. They will have their own answer already. They don't need to ask. They can just ask themselves. And like I mentioned here in point 3, you can build up any projection you like. You can even go back in time, build a new projection, also known often as read model. And yeah, this will give you the ability to answer your own questions, really, without asking, and also without other services needing to add extra endpoints to their APIs. Basically, you don't need the APIs anymore, you just need the events so that you can do your own thing with that. All right, so this brings us to the conclusion in which I think that we can still have this system. There are these services that are interrelated. They do some great work together, but these lines no longer mean that they are making calls to each other, but they are listening to each other. So they are just having their ears open and doing, or basically responding to what is ever happening in this system. And it's said that this is sort of the difference between orchestration and choreography. So with orchestration, you have explicit directions for everyone to do this, to do that. With choreography, you're acting as a group. It's all dynamic, but you know the clues. Like if somebody does this, then you also do this, or you go that way. I'm not sure, like I'm not a dancer nor an orchestrator, but I can see something about that similarity there, and it's a different approach. The only thing you need to do is just make sure that you publish the things that other services need to know, so that they can respond, and everybody is like sunny microservices there. Or, I said micro, that's not a good idea. Like services is good enough. Anyway, like 3 services is already good enough. Like maybe 2 is even good enough. And then if 2 is such a hassle, 1 is good either. Okay, one last thing is that, it's not all black and white. There is a bit of gray there, maybe, I don't know. So this is all black and white, black or white. The thing is, we have this goal of making things really autonomous, completely autonomous. This will lead to a lot of extra work. Like with every programming idea or design technique, you should think about where do I apply this, and do I actually have to apply this everywhere? And I know as a programmer, you want to apply things everywhere, just to be sure. And this is true at the code level. We want to have code formatting everywhere the same, right? And then if we encounter one file that's in a different format, it's really horrible. We get upset about that. But in fact, we don't need to have it everywhere in the same way. And it's true for this kind of thing as well. Just make sure that you place these strategies or like these techniques very strategically. Where things have to be really autonomous, make it autonomous. Like for an e-commerce system, it's important to always be able to accept new orders, right? You should never say, no, I'm not accepting your order. You should just accept it. and then look if you can make it work for them. Even if all of the backend systems are down, still accept them. So this is an example of where it's just very smart to be autonomous. But then again, if something in the background is very stable and you can just make calls to it, yeah, by all means, just make that call and make the query or make the command call. So yeah, you don't have to go all the way because it will cost a lot of effort for you. And in fact, this is an article or a set of articles collected by Martin Fowler, who needs some advice on CSS, if you can see that. This is really just a screenshot. I don't know. But yeah, it's not just microservice trade-offs. This is really about making things independent, and that's it costs something. You have to have better monitoring, maybe better deployment options than just one script deploying everything. So yeah, just read about that and consider if it's for you. It should not just be like we have to have it this way, so we're doing it. Yeah, it has to be there for a reason. Otherwise, I think with want to take another picture? Yes, the slides should be online as well. But this is the way I envisioned it. That currently we are sort of peak microservices, I think. In a sense that the hype is gone a bit, I feel, at least on these kinds of conferences. It's not like we should hop on this bandwagon anymore. We should be more careful about that. But in terms of technology, there are lots of easy-to-use things in terms of build pipelines or like tooling to set this all up. And I think in that sense, we are past the early adopters phase, and we're not risking lots of dangerous technology decisions anymore. But like this is my feeling about it. I'm not sure. I just feel that there is the sunny side there, and if we can fix all of these autonomy issues, we don't end up with all of those shitty distributed monolith things. We end up with really good services that can do their work without relying on other services to be online. So I really hope that you can succeed in that. Definitely let me know once you do, so that I can get some feedback on this advice as well. And then, well, with a nice purple slide, thank you for listening, and yeah, let me know. Okay. Thank you very much. Do we have 5 minutes? So if you want to ask, yeah.
So suppose you have a service that you send a query, but the service becomes slower and slower, so you want to rewrite that query to like event the other way around, but you don't have the history for all the events. Yeah. Do you have advice on that?
Yeah, that's where, as a migration, let me repeat the question. So one service makes a query to another service, and we feel it's still okay because it's responding quickly. But then at some point it's going to become slower or buggy or whatever, and you want to get rid of this query, but you don't have any events to rely on. So you cannot just replay history and start building up your own current state. So in that case, the migration is not like a database migration, creating new tables, etc., but creating new events. You can always guess what the event should have been like, and they don't have to be even the same events as the new events that you're creating. So you can just have some sort of a migration event with all of the data inside of it, so that at least the other systems can know, or the other services can know what has been sort of going on in that other service. Yeah, so migration is creating more events, and not necessarily of the same type as the domain events that you are introducing now. Yeah. Okay. Yeah. There.
It's not really a question, but I just want to add that the hype has not gone actually, because software architecture conference last October in London, and the main topic was microservices.
All right.
3 times in a row, I think, of the conference. All the other years they were skeptical. Now it was the main topic.
All right. So the hype is not gone. Something we can remember now.
We'll see this year how it will be.
Okay. Okay. Yeah, but we still need the good advice on this topic. Yeah. Okay. Yeah.
So we build this thing, and we have like maybe 5 of these apps, but they're kind of connected by APIs and queries, and and I don't think the system is ready to go maybe to an event-driven system yet. Like, could you do like a half measure and kind of have events, but they include all the data all the time. For example, add something. It's going to be a lot of data there, but then all apps can like have separate queues and like read from them and handle them whichever time.
Yeah. So the question is, do we need to go all the way, or can we at least do something like this changed? Here you have all the data. Yeah. Okay. Yeah. So of course, basically, my advice is always you can do anything you want, and it's not very bad because you start with at least some events and some reactiveness. You respond to certain things happening somewhere else. Also, if you want these really fine-grained events, you also have to see this in your modeling effort. So yeah, if you still have CRUD things in one place, by all means, like dispatch updated, created, deleted events. That's perfectly fine. Also, some services may not be interested in all the fine-grained events. In that case, you could just start with doing like really high-level events. Yeah. Okay. One question, last one.
Is PHP and Symfony, is it ready for microservices?
Is PHP and Symfony ready for microservices? I would say use no frameworks at all, except for maybe the things that you write to deal with this. Most frameworks, including ORMs, have issues with memory. So they will, like PHP is used to, or PHP developers are also used to processing one request back to one response, and then all the memory will be gone. And you don't have to worry about memory leaks or like being inefficient with memory. And this is something for the long-running processes that consumers are, that you should be worried about. So I'm afraid that Symfony itself may not be ready for it, but yeah, you probably don't need it at that level. So the web applications themselves can still be Symfony, and then in the background, all of the services can just be plain PHP with some of your own libraries. I don't know if there are really good libraries for PHP that help you with this kind of thing. By the way, anyway, you know.
Well, I know there's a lot of effort in the Symfony department to make long-running processes better, but
yeah. Okay, so there is effort, and PHP PHP itself is ready as well. It's just that some of the tools are not very much built for that. Yep.
I did this wacky trick where the command would exit itself, but you have supervisor who kept repeating the command.
Yeah. Okay.
But
So
it has a startup time of 250
Yeah.
milliseconds.
Yes.
Like it's a sort of polling, so that's
Yeah.
a crappy solution, but it worked.
yeah, sounds good. Yeah, well, to prevent memory issues, you can just restart the process. That's the suggestion here, and let it just. Yeah, fail early. Yeah. Okay. We have to stop here, and thank you for participating, and see you. Bye bye.